My name is Badyan, and today I'm going to talk about orchestrating serverless flows using AWS Step Functions. Okay, so this is me. I've been a software developer for about 12 years now. Currently, I'm a tech lead at Vonage, working on a lot of serverless technologies on AWS. Let's talk about our product. So our product is a virtual phone system for businesses in the cloud. Our users get phone lines, call queues, virtual receptionists, and many other features. Basically, they get a phone system that's hosted in the cloud for them. They receive hundreds of thousands of calls every day, and some of those calls go to voicemail. So each one of those voicemails needs to be handled. We're transcribing them, which means translating speech to text. And also, we want to transcode the audio from a WAV format into an MP3 format and send that result by email. So let's say we want to implement this using a serverless way, right? How would we do it? So the naive way would say, okay, let's take our code, write it up, and just put it in a Lambda, upload it to the cloud, and that's it, we're serverless. So what's the problem? Basically, you get a huge Lambda. And that can be a problem in itself because Lambda has some limitations such as size. We've seen this 50 mega size limit. So that can be a problem. But also there are other challenges. Every change you make to some part of your flow means you have to redeploy your flow in its entirety. You cannot reuse any part of your flow in other components because everything is inside this huge monolith, right? And the other thing, if there are certain parts of your flow that needs to scale independently, you also cannot do that because each Lambda is, again, in the entire flow. Okay, so we thought about it some more and we decided to split it up. We make several Lambdas, right? So what happens next? We're using some sort of queue-based solution. How does it look? We have a Lambda publishing to some sort of queue and another Lambda pulling from it somehow, and that's great, that works. It works for 2 Lambdas. But what happens if you have dozens of Lambdas? What does that look like? It's pretty messy. You have to start figuring out what goes where, which Lambda is first, which one is second, which one is 23rd. You have no holistic view of your process, and that's a problem. I think there's an underlying issue here beneath all this that's common to this theme. And that is the lack of state. When you work in serverless, you don't have any server, by definition, right? To have a shared memory or disk storage that you can use to sync your flow. And that's a problem. You start looking for solutions. But what if somebody kept that state for you? What if there was somebody like that? Well, there is. One solution for this is AWS Step Functions. Basically, it's a state machine that you can use to chain Lambdas together. Let's look at a simple example of a 3-stage process. We have the first Lambda that gets the data, another that does some processing, and another one that sends it somewhere. Each one of those is developed, tested, and deployed separately. And you use step functions for the glue. You define the states and the transitions between them, and that is your look of the flow. Let's see how that looks. This is an example. You see, you write a JSON file that's a template. It's a declarative JSON. There are states there and transitions and other things that we'll touch upon. And you all get an automatically generated visualization, which is pretty useful. So how did we use these features to implement our flow? First, we use a conditional flow. Not all voicemails need to be transcribed. It depends on user settings, on environment variables, and other factors. So we have that option to skip invoking a specific Lambda. Another thing is parallel work. Some parts of your flow are not dependent on each other. We're uploading our files to S3 in order to transcode them later and transcribe them. Also, we need to notify our users that a new voicemail has arrived. And these are not related and can be invoked completely independently. A great feature that's built into step functions is the ability to do error handling and retries. You just define which exceptions you expect your lambdas to throw, and then you define the number of retries that you want to do, or however you want to handle it. All that is application flow logic, and that's completely separate from your business logic, which is inside your Lambda. And that's very important, this separation. It allows you to reuse and do all sorts of really cool things. One other way we use this is for a polling service. We use an external service for our transcriptions, and it works with polling. So what we do is we make a request, ask for a transcription, we wait for a set period of time, and then we query for the results. If the results are ready, that's great, we do more work. If not, we just wait some more and all over again. I think one of the key features of Step Functions is its ability to scale. What you have, each voicemail is implemented with a separate invocation of a step function. That means you have an isolated flow that's unrelated to anything else going on in your system, and each Lambda invocation is a separate Lambda. It doesn't know about any of the other Lambdas, and that means you have infinite scale, or almost infinite, depending on your account limits, of course, but much larger than anything else that you would be able to do. So how does it all look together? This is our flow, an invocation of it. You can see that this visual flow shows which states were invoked, if we had any fallback states that we reached, or any other issues that we had during the invocation, like failures and stuff like that. So it's pretty nice, but is it perfect? I don't know. I think it can be improved. I'll explain. AWS doesn't allow you to nest step functions. This means your entire flow has to go inside one step function. Why is this important? The more complex your flow is, the more you have to scratch your head and figure out what's going on where, like we've seen, like it can get complicated. So it would be really nice if we can modularize them into separate step functions, but that's currently not available. Another thing is, a step function is not code. Eduardo showed us an example of how it happens in Azure. They do have something that allows you to write functions, right? Actual code. So AWS doesn't have this yet. So there's no ability to customize. You only have to depend on states and transitions. And that's powerful, but sometimes it can be limiting. Integration with AWS is not perfect. So the only ways to activate a step function is using API gateway, CloudWatch events, or a direct SDK call. And really, for most scenarios, that's adequate and fine, but it leaves more to be desired. And finally, cost. Ron talked about it in the previous session. Lambdas can get pretty costly. And when you add the step functions, you also have another layer of cost. You're paying for each transition. And when you have a complex flow, it can get pretty heavy. So alternatives, we've seen Eduardo showed that Azure now supports something similar to this. Also, if you're not in one of those clouds, you can use an open source called Conductor by Netflix. I think that's the most popular one that I've seen. There are others, but not as prominent. So conclusions. What did we see so far? S is for step functions, because it's awesome and powerful. And it really provides you with scale and the ability to add advanced flow features, retries, exception handling, and all that's built into a declarative, nice, pretty package. Does it fit every scenario? No. If you have a complex business flow, it can get very, very complicated for you to debug it, to understand what's happening, and I would suggest you separate them. So what's the best fit? I think some sort of a medium-sized flow that's well-defined, that you understand the business requirements for, and that should be good for you. Any questions? Yes. Question was, how do you debug it? You don't debug the actual step function, but you do have the ability to add something that helps you. For us, in our flow, each log line that the Lambda emits adds a correlation ID. We send those logs into a centralized location, and we can then query by this transaction ID. We get a view of the entire flow. And of course, you can debug each Lambda independently. Okay, thank you very much.